Alrighty, let's do this. Gonna be a quick one, hopefully easy. It's no more jump games, finally. Count the number of special characters, part 1. You're given a string word. A letter is called special if it appears both in lowercase and uppercase in word. Return the number of special letters in word. Okay, so both uppercase and lowercase. A is special, B is special, C is special, so 3. None here. B is special, that's it. Okay. Pretty straightforward. I just need to take account. I think. So I assume the word is only, it's only 50 long, only uppercase and lowercase letters. I can make the set of the word and then see if certain combinations are in the set. Probably. So I can create the set of the word. Let's say, I'll say lower is the lowercase alphabet A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and then uppercase, I'll say is all that A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And then I'll just create the set. So the uniques, I'll create the set of the word. And then answer is going to be the counter for every index k in range 26. I think I need to have indices here, right? In order to progress in both arrays. If lower at k is in the uniques and upper of k is in the uniques, then answer increments, and then return the answer. Alright, there might be faster ways of doing this. Almost certainly. We'll see how this one goes. Most kind of straightforward way, I think. It's a little slow. Okay. Alright, so let's go ahead, and the other way that I think about doing it would be, what would be the other way that I think about doing it? I could iterate over every character. So this is generally one pass. Yeah, this is generally one pass. Can I do it in a single pass on the first pass? If I store each lowercase letter. Okay, let me say I think I might still need uppercase and lowercase strings. So if I do a single pass where I go A, cap A, and look, this would be so much slower. So I'd store the set of lowercase, and then I store the set of uppercase. Okay, maybe if I had a dictionary that was just a little, oh god, This is going to be disgusting. Okay, actually, I'm going to do a pre-compute dictionary here. So let's say mapping is going to be a dictionary, and then for every index k in range 26, mapping is going to go from lower of k is equal to upper k, so it maps from lowercase a to uppercase a, and also mapping from uppercase letter to lowercase letter. Go ahead and print this out because all I want to do is get the actual mapping. Okay, and then go ahead and create this and do something like for every I'll have a scene set. If for every let me think about this. How would I do this? Okay, so let's say for every letter in the string word, if the mapping still has the letter, if letter is in mapping, I'll go ahead and remove the mapping once it's been used up. But if the letter is still in the mapping and scene, or the capitalization of the letter, which is mapping of the letter, is in scene. So like A's there and capital A has been seen, and then I'm going to do answer increments. Oh, what am I doing here? Answer is initially 0, answer increments here. And then remove this thing from everything in consideration. So mapping dot remove the capital letter. So mapping at letter, remove that B, and then mapping dot remove this letter. I don't think I need to worry about being insane. Actually, I think this needs to be 2 parts. So if the letter is in mapping, and then if the letter is, the capitalization of the letter is in, otherwise it's on the first step, and this is the first time I've encountered this sort of combo. So else scene dot add the scene dot add this letter. I think this might work. Dictionary has no object to remove. Is there a dictionary discard key thing? Is it remove or discard key? Pop. Interesting. Or delete dictionary key. delete dictionary key. So delete mapping at letter. Oh, the dictionary is called mapping, and then delete the letter. So I'm deleting both the capitalization key and the lowercase key. I don't think this seems so much slower, but it is one pass for what it's worth. Oh my god. Okay. Alright, that was something. Alright, let's see if I can't just randomly get 0. Let's going back to the original way. Yeah, this was creating the mapping, right? Uniques of the word. You know, I wonder if I made this a set. No, this has to be array. I'm indexing it. It's an array, but I wonder if I made a set. Okay, let's just rerun it and see how fast it goes. It's still 1 millisecond. It's definitely not 0 milliseconds. It's not 1 millisecond again. Is there a fancy trick I'm missing here? Or maybe not a fancy trick. Is there just a trick I'm missing? I mean, I can stop early. If this is 26, I can just stop. The length is only 50. I mean, I could use a Boolean array, I guess, rather than a set. Yeah, I guess I can use Boolean arrays. Does that make sense? Does that make sense to use a Boolean array? I mean, is creating a set from the word that slow? I create a counter, but the counter is still the same deal. For every letter, create the lowercase of the letters in uniques and uppercase of the letters in uniques. Can I? What if I did something like, if I create the mapping still, but the mapping was only for the capital letters? Oh shit, this is everything. Gosh. I was thinking about iterating over the set values. iterating over the set values instead of iterating over every letter. Gosh damn it. Let's go back just a few steps to where I create the mapping array. Okay. Where I created the mapping, not the array, but the, why didn't it print? Not the array, but the actual dictionary. Okay, so this is just the uppercase and lowercase. I'll say this is the half mapping. And let's go ahead and comment all this stuff out. Okay, so I create the unique set, and then maybe I iterate over those uniques. But then okay, well, let's just see how this goes. I don't think this is actually any faster. Yeah, this seems slower. For every unique in uniques, if unique is in the half mapping, so it's the lowercase letter. Actually, maybe I should just say if unique is in lower. Unique is in lower. And the uppercase version of that, which is the half mapping of the unique, is also in here. Then answer increments. I don't think this is faster. This seems so much slower. Uniques. Now I'm just changing my spelling for no reason, besides making errors. Oh gosh. Keeps on getting worse. I don't know. I don't know. At this point, I am up for getting 1 millisecond. The other thing I need the array because I'm iterating over k, which is an index. So creating the set of all unique letters. I wonder if there's a really fast version of like upper or lower that I can use and then do some sort of comparison. Convert the word to upper and then see how many characters are the same or different in each. Then that doesn't count uniques, does it? That doesn't count uniques. Alright, yeah, I'm done. I am done. So I'm stuck with whatever, 3 milliseconds. 1 millisecond randomly. Answer is not local. Excellent, excellent. Alright, summary. fuck. Okay, so this was my original answer, and now it's 0. Okay, excellent. A lot of time spent doing nothing of significance. Basic idea is to create a set of uniques for the letters in the word. Once then iterate over every kind of lower/uppercase letter. In this one I use a single index that iterates that indexes into two strings that are lower and uppercase letters. That indexes into two lower and uppercase alphabet strings, and see if the lower and upper version, uppercase letter appears in the unique set. So that's going to be at most 26 things, right? Timeplex we open to create the set from the string. It's going to pass through all n letters and then create the set, and then it's another 26 steps for that. Base complexity is going to be O of 1, since the set has at most 52 characters, unique characters.